right, so I'm going to basically talk about network security tools as they apply to the various BSD operating systems. This is an updated version from my talk I gave at BSDCan. First, there's a little introduction. We'll talk about cybersecurity, discussion about what NSM is. The main part of the chunks of slides I have are just talking about running the tools on all the various BSD operating systems, so I'm going to try to squeeze that in as best I can. I might gloss over some of the specifics that I have in my slides. I will make my slides available on my GitHub after this talk. Then at the end, we'll talk about just BSD advocacy across the various projects, and I'll talk about the problems I have with log data. Whenever you see BSD, basically this is going to be a rant warning. I might not have a very specific reason, just maybe I'm angry at something, so that would be just kind of my citation for it. Everything I've marked with an asterisk will be just based on my personal experience or someone I might have spoken to that's just without a citation. But then everything else, I have citations for what I'm referring to. So I've worked in IDS IPS since 2003, mainly Snort, Suricata, Dragon, and I've also been working with Bro, some of their various vendors and their products. Always been doing signatures for emerging threats, as well as some research and into exploit development. At this point, I maintain pulled pork for Suricata Snort rule updates, and pretty much as far as FreeBSD, OpenBSD, hardened BSD, as far as my use of the operating systems, and Snort's, Suricata, Bro, and Aid for the tools, the open source security tools that I use. Cybersecurity, as it was then called, maybe information assurance a few years before that, I called it network security. I like the term InfoSec personally. So you're focusing on the protection of electronic data, anything that's labeled cyber, people really get excited about. You're securing electronic data from continuous, as things have gotten more complex with cell phones and any type of ways to try to make things usable for people, have just made security problems that more of an issue. Thinking about mobile phones, Internet of Things devices, etc. Always stick to the triad. There's also I didn't have in my slides, the McCumber cube is a way just to break out the idea of confidentiality of the data, that knows that only are allowed to see it. The integrity of it hasn't changed in rest or in transit, and the availability of that data. So it's trying to maintain this to keep your systems online, available, and secure at the same time. So you have strategies. Always hear defense in depth, multiple layers of security on top of it. Then the idea of continuous monitoring, where there are guidelines, NIST guidelines for the risk management framework. So you're just knowing what's going on in your environment, doing vulnerability scans, and just being aware of things as they happen in the environment. And then this idea of network security monitoring. As defined, Richard Bakley here, so network security monitoring is the collection, analysis, and escalation of indications and warnings to detect and respond to intruders. Basically try to get as much information as possible about what happened and then be able to react to it, to respond. And he kind of wrote the book on this idea of network security monitoring. This is a great book you can get from No Starch Press. The first book was The Tao of Network Security. He wrote back in 2004. It's just if you have any other specifics besides my slides, which has a lot of information, this is another book to take a look at. Basic idea is that prevention eventually fails. We still have IPS devices. I've been in this field for a number of years, and still we still have users, we still have things that happen that we have to work around. So it's the monitoring for these potential threats, responding, escalating, and it's this cycle of plan, resist, detect, and respond. So might remember that name. He did a talk at BSDCan in 2004, and I think he did a similar talk BSD Con that happened in 2009, just talking about this squeal as a tool, and as far as for collecting a packet that you'll see in the next slide. But this was back when he did his presentation, wasn't even a port yet. And it's not the prettiest of interfaces. It's Tickle TK, I think still to this day. But you have all the information as far as alerts as they came in, the information for source destination IP 5 tuple, then going over to the specific signature that hit, what pattern it had on the network, and essentially everything an analyst would need from this perspective to take the next level to say, oh, this is not that big of a deal, or this is something we need to take a look at, escalate, and respond to. So whenever you get an alert, it is, you get full packet capture session data. There's no question about why something happened. And of course, for the openness of the signature language, you're able to determine quickly what happened. And we get to a point where now it's kind of like when finding if something happens, it's like the term kill chain, which I laugh at because it's actually a trademark term. So this is 2004, 2003, 2004. So it's great to have NSM. You fire up this box and you have a database. But the issue, even at the time that was discussed amongst anyone in the security community, is what do you do with all the logs? I got, at the time, maybe it was like a 1 gigabit link. How am I going to log all this data if it's going to a database? So there's already problems with scale and how to actually deal with this, with the potential to scale up further. But I hate databases. So I came up with the way it's like I have text files. I got firewall logs. I have the alerts that come in, PCAP data. And that's enough to do my own system even without a database. So for my Ghetto NSM, it was my home network. It wasn't really, not getting attacked by too many people. But I could apply the NSM concepts even at a small scale. So older signature hit that I received, I get my alert that says where source destination come from. Then also had some session data, just in case there was something that might have triggered an alert, but if it was like an HTTP thing that was coming in, but it wasn't exactly a web request, quickly determined if it was actually a session that was created and meets for the protocol. And so this was just a PHP scanner that came in with the different PHP remote file inclusion attack, an old general signature from emerging threats. So took that, found a new PHP scanner that someone was using, and then that turned into something that escalate and create a new signature for so that if someone else is using this, then I'm able to determine in the future that someone's trying to scan for PHP vulnerabilities. So it's it's just an example of what you can do. So it's like about 2010 when we're looking at the fact that Security Onion was kind of the easier way to get all this stuff set up. You don't have to worry about setting up things. It's ready for all the tools, including Bro, Suricata, and Snort as far as the network detection engines that are on there, but then all the other tools. And for users, it was easy to set up. You just install it and run with it. But all these services includes databases, web services. A lot of the tools themselves had PHP front ends to them. And the main problem was it's the OS that we just can't get away from. For anyone that doesn't, does anyone really love Linux? With the exception of Dan? Okay, got one. So this is kind of trying to tie what at the time was some of the reasons that people that were using BSD network sensors were starting to move away from it as a platform. And I try to tie it to when things were changing as far as for FreeBSD and SMP work. And it's about that 2003 time frame when some of that was starting to come into FreeBSD, but Linux support was getting better with drivers, and what we saw was a lot of the vendors were starting to move away from their BSD-based appliance. I have network stacks. I don't have much info as far as for comparisons, but just the driver support, and hey, we can just run this Linux box. Why are we going to stick with this BSD system if we can get everything we need from a Linux box? But I didn't do it. As the other products were developing as far as for IDS, I was always angry at the fact that they closed their languages. Even though, yes, Snort's the de facto standard for things, they had their own way of doing signatures, which made it difficult as an engineer to keep this system working, trying to make new detections and put them in place. Just like Trons, if you notice, from the old IBM, what's now IBM, but it was Internet Security Systems. That was their tool to take Snort rules and make it into a format that they could just simply import. But for anyone that wanted to not run one of these, your options were essentially, hey, I could run security on them with whatever hardware I have lying around, and you get your signature detections the same way as you would with ET Pro. You can pay for the VRT signature set or any other threat service. And I know people in the community love BSD, but it's like, well, not going to really get too interested in it if all the vendors are actually using Linux as their platform. Just because it's easier doesn't mean it's better. So in looking at a way to try to, most people just have a small business setup, they set up Security Onion. But as systems grow on, you have login requirements. If you're doing a federal contract work, it might be PCI, FISMA, whatever security needs you have. You can't really just have this single box that's set up to do all of your logging. And I'll get into logging a little bit later. But even with these solutions, you could essentially just have a box that's a network sensor. It's all it's going to do is be reading packet data. And in one instance, it was a Linux box I had to take over and work with. But it's essentially just a bare-bones system with Bro and Suricata running on it. And we'll discuss the tools a little bit later. But the tools like a Gigamon, like for a network tap, take the network traffic and move it around, or an Arista front end. There's no reason why you couldn't use a BSD box to be doing this. So the grouping of slides I'll be jumping through is going to be for the tools. Like I said, I'll have specifics of the things I found on each of the operating systems and more of an introduction. I'll check if anyone really wants to dig into it, but I'm trying to get questions, so if we have anything, try to space them back to the end. And I have updates, but most of this was all testing I did in June, so some things might have changed with versions, but this is all based on testing I did. So anyone not familiar with TCP dump? No one? Okay. Oh, okay, just at the end. Yeah, so developed in the 80s, pretty much the tool I've used more than probably that and SOCStat, NetStat in the world of trying to see what's going on for network stuff. Normally removed from systems for security reasons, but makes it very difficult to test things. So for each of this, both FreeBSD has an option where if I just want to, I'm basically going to record all the network traffic. So I can set up a directory structure with naming format, and this will essentially roll every 60 seconds for, as network traffic comes in. So that's just something you can do with TCP dump, just to record network data. If something happens, go look at your PCAP data you've been storing on your devices. Dragonfly is the same way. For both OpenBSD and NetBSD, they don't have that G option. So I just made a script that kind of does it. This does have some issues with it because there will be a time where you're doing the kill. But it was just a simple example of how you can start monitoring your network, start rolling PCAPs and having an idea what's going on. So Marty Roche wrote Daemon Logger about 2006. So this was actually more of a better enhancement over TCP dump, plus the ability to set it up as a software tab. So you kind of a similar structure for how you would set up with an underprivileged user to do that same login with TCP dump, but using this tool. And it's a little bit better for moving and the buffering, so you don't have those issues of stopping and starting the tool. Same for Dragonfly, which mirrors the same package repo. Issue at the time with running on OpenBSD, I still need to look at. I think it was something with the package that just doesn't run, so I need to take a look at that. And NetBSD had some issue with the size notion. So Time Machine is one of this when I think about the tools that I'd like to see working well. This is something that is being used, but think about I'm running PCAPs and you have a 1 gigabit link and you're just taking all this data as it comes in. But once you start getting up into 2 to 4 gigabits per second range, that's back to that point I made about you're saturating your disks trying to log data and then you're not going to be able to store it. So this just sets a buffer inside each packet to pull the most important parts of the data. And as far as for Lawrence Berkeley Labs, they're doing these multiple gigabit per second links for research networks. They're able to take what would be 17 terabytes per day of PCAPs and boil that down to 150 gigs. So you have 30 days of logging of very fast networks. So I think this still works on FreeBSD 11. I just don't know what the issue is in current yet. It just doesn't build. It's like various issues. I'm still working on that. But you would essentially just do the package install to get the baseline, and then you build it from source. There's some configuration tweaks to get it running, and there's other things to cover as far as when it's running. It's then how to communicate with it, how to send it data. So the idea would be you have most of this running in this ring buffer, and then when you see an event that comes in, you say, I really want to know what's going on with this. Give me all the network traffic from this source destination port IP. And it will dump it to disk and you have that data. So it's an interesting tool. And that basically is what Bro folks are using as far as a way to capture data. Now Bro's late 90s, Vern Paxton's research work. Essentially, it's a network framework. It's a programming language to explain networks. So it's not that it's doing signature detection in the Snort Suricata sense as much, but breaking down the protocols and telling you what's going on. My main use is definitely threat intelligence for your file hashing. If you have a specific URL that you're using, so as you can build out a great way to look at the network for threat data. Scalability is built into it from a single box we talked about, and if you have more network sensors, it has its own ability to scale up in a clustered configuration that's unique to the tool. And of course, it's a good BSD engine license. So some things beyond just the log we'll talk about in a second. They have a high, bin pack is like a high-level protocol parsing code, and essentially you can build tools and then use those for your other various research, because Bro is very much like an academic type of tool. Even testing more low-level, how does your low-level type of network stuff work? The high-level intermediary language, so for deep packet inspection testing, and then with this as a platform for low-level analysis, using that to build Spicy, which is built upon it, that is just defining your own syntax. You can basically just building out your own types of detection tools. Not typical, just something to highlight the capabilities you have with the engine. Like I said, research tool for the most part, but a lot of people use Bro to monitor networks. This is just a progression where, for the most part, you'll stay on the top tier for just a standard Bro log. You fire it up and run it. If you need to modify or tweak things for IRC sessions, as an example from this slide, then all the way down to more, you might want to make your own analyzer. Essentially, you have the framework in Bro to do this. These are types of outputs. When you start up Bro and it starts looking at a network traffic given interface, these are the types of logs that you'll get, each one kind of self-explanatory, but for like HTTP and files as they download. Example, the connection log, all connections as they come in and out. Bro has its own way of kind of interpreting that. And then later you can do analysis on this data. Always keep a copy of the connection, like the specific state. So it's not just like TCP three-way handshake, but kind of what happened. So with like the source of this traffic or the originator and how it was responded, so you can get, like glean very interesting information from the network about what happened in the connection. Most useful log for like HTTP, so it's not good because it's tab separated in this log format. But URL, domain, if something weird's coming in, you could basically do an analysis of user agents. Like, what's the top user agent I'm seeing hitting my web servers on the monitoring link? And you can do a lot of just baseline tools, nothing fancy here as far as these are all command line stuff. To like enable the Intel framework, this is just an example for how you redefine the scripts that run with Bro to then add the Intel, so that every time I get an Intel hit, send me a notice alarm, and then I get that information for some Intel hit that occurred. And this one I tried to fit in the slide. It's just showing how once you take an action, something occurs that you really care about. At the bottom, I'll try to move my mouse over. The section down here is essentially launching a script. So I see something on the network, though it's not an IPS per se, and I can take an action based on what I see. So beyond that simple IP blocking setup is this Justin Azoff, so I'll be seeing next week as the Bro conference is coming up. Instead of using just a direct script to do it, using black hole routing. So if something comes in, send out advertisements to basically block it from even getting close to the network. So it's kind of like a reactive approach to use with Bro. Package now is up to 2.5.1 on Bro. So essentially just a package install and set up just through localhost. If in this case was just doing beehive testing. There's defaults for where logs go, where it basically the spool dir is where when it starts up, it starts putting stuff in there, and these are all defaults with the Bro package. The RC script has also been updated, so now you can just simply do a sysrc to enable it, and then do your deploy, and you're up and running. Same for Dragonfly. I just put this comment in my slides because I don't know what happened during my testing, but it was just a weird thing. I had to remove a package and add it back in. Not sure if that's still an issue, but otherwise, same information for FreeBSD. The Bro package was 2.5 when I did this originally. So 2.5.1 is going in, I believe, once 6.2 is released. The only thing here is like if you're just new to OpenBSD, this is how you do the first setup of the package repo, so whatever your architecture is, doing the necessary pieces, the linking, the Python, that makes your life easier. Little different structure for where default loggings occur, and just getting it up and running. NetBSD, there was no bro package, so I tried to do some building, and there's some build issue I have to take a look at. So it's 2.5.1's the recent release, and some things later I'll be discussing. With this bro package manager is a new thing they've added. It kind of changes the way plugins and stuff work, and it's very specific to the network technology, NetMap. We'll talk a little bit later. So you have Snort. Most people probably have heard of Snort. Always referred to as the de facto standard for a very long time. Been always been a large signature set with the additional protocol support. You can basically configure it inline or just open with like a passive monitoring. The only main change is with the data acquisition was a later thing, so it's a separate library, so you basically tell it, okay, what type of acquisition do you want off the network? Do you want to use a libpcat base, netmap AF packet if you're running on Linux? The various types of rules, standard rules, what most people are, if they've ever worked in InfoSec, someone's at some point had to write a Snort rule. Also preprocessors and decoders that can help enhance, do some more of the low-level stuff. And the shared objects that were added that allow you to write code into the engine to do more complex detections. You can't just do in a text-based rule. GPL v2 license, which you can use for your own use, but of course, if you're going to sell it, there is some integrator license and the signatures themselves, just for to make sure that you pay a license fee to get access to their signatures. So this is an older Snort rule where it was just a basic text-based alert looking for if someone's compromised a root box. You get your UID equal to 0. As it moved on, you get your more complex operations, the byte test, and so just moving on, adding more things that can allow you to detect things on the network. But for some cases, as this is an instance of a type of Samba NetBIOS type event, even building more as things have evolved. So like for the DC interface for DCRPC, the binding interface, and things that make this easier for the signature writer to take care of complex things. Because if you think running Samba is hard, try to detect the garbage that's in this protocol. There's thousands of rules dedicated to trying to do every which way that a single vulnerability can be exploited across all the various protocols. So just example from the conf file. So for IMAP or POP, just like here's some detections that are built in. You don't have to worry about writing signatures for. If something's anomalous, you get a signature hit on it. And shared objects, like I was talking about, there's just a reference to it in plain text, and then you have to build a shared object that goes along with the engine. So when for the port number, when anything occurs, it then looks for that shared object ID, and then that's what comes down, and it feeds out to that shared object to do the analysis. So on FreeBSD, simply install the package, but there's some other stuff, and I'll gloss over it, but essentially I call this the Snort magic that I need to get worked up to do configurations, including setting up pool port, which comes down to help set up your rules, but you have to go in there and set up the information that you need to get it working for you. So that's all what I call the Snort magic, some thresholding. And like I said, I'll have this in slides for afterwards. Unified output's the main way you want to run if you can, with just running out to the binary format. And then you have another tool called Barnyard that will just read in the data. And this is I'm just putting up here as an example of what you get. Hey, someone's trying to do this remote file include attack, and what you would see if you set up syslog output. Same stuff for Dragonfly, so I'm just going to skim through that. OpenBSD, the only thing with OpenBSD is I just had to pull port, but the Snort package is there for you to simply get it set up and running. Same Snort magic. NetBSD had an older version of Snort 2.8, and the thing is that doesn't have any new signatures coming out for it. So the engine will work if you set this up on NetBSD, but you won't be able to get any signatures because they have an EO end of life that they do for the engine version that you have. So Suricata, of course, I don't know if anyone using Suricata as a couple. Came out after some of this concern over, the engine itself, with the ability you can't really resell Snort. You're supposed to pay the license. So the effort is make a highly scalable, multi-threaded network sensor, and then have that available with a license, and basically with the support staff that's a foundation. So multi-threaded high performance, various performance options, you can tweak stuff. And if you have Snort signatures, we'll see in a second, you can pretty much bring those over without having to do too much. But there are differences. There's a nice talk about just the subtle differences that if you bring stuff over, you might have some issues. So the main thing is throughput, and there's a pretty good community around Suricata. And pretty much the same format you saw on the previous slide, just stuff like in the top left corner where you have alert HTTP. There's ways to do things where it's, okay, this is a specific protocol, so this would only apply to this specific protocol, instead of having to worry about what port it's on to enhance your detection. Same for TLS and SSL type of detection, looking for certificates. So look across any ports to try to find a vulnerability. Same for package install. Jump that. And just doing the settings. This is the same way to set it up so that pull pork works. And this is probably the same thing that tweaks and stuff that you have to go through and get this to work if you want to make sure you're automating your signature updates at whatever interval you want. Just JSON output for the eve.log, where you have you can dump the payload data, and this is something you can feed into your logging system. This is not, you just have to turn this on. This is what they're moving towards as far as the output mechanism for all the various logging tools. Not sure what the issue was on Dragonfly. Still need to look at that. And Suricata does build on OpenBSD. Just have to compile it by hand. And the rest of the setup is the same for as you would for changing the configurations. Same thing. I'm still good on time for the most part, but just going through it. Did not work on that BSD. Still have work to figure out what's going on there. And 3.2.3 came out. To get this out the first time at BSDCan, I think they released every beta that day when I was about to give my talk, so I try to make sure I keep this stuff up to date. 4.0 came out. It's the current stable version, and they've added experimental Rust support to be able to build different protocol analyzers in Rust. Not something I usually do too low level, but they've started to do things like a DNS type of protocol analyzer. So that's stuff that's coming in by the end of this year. Hopefully they'll start, it's something that you can actually use in production. So a lot of this, we'll call the magic, is stuff I've automated, and I just have my script out there. So if you're running FreeBSD, you can use my script to just set up Bro and Snort. I got to get Suricata added. And we'll just take you through the process that once you have all you got to do is register. The one thing I glossed over because jumping through the slides. To get Snort signatures, you have to register at their website to get the free license. You get delayed signatures. You take that code, you basically plug into my script, and it does all the rest of that in-between stuff that you need for you getting pull pork to work with your signature updates. Of course, you got a FreeBSD box, you can run it in the jail. You set up basically the access for the jail for the BPF module, and essentially, I did this because someone actually in the Bro community was like, well, I'd like to do that. I'd like to use FreeBSD if you could tell me how to do that. So I wrote that up on my website to just simply set up the Bro jail, and you're logging your data. So the NIC offloading features, this should work at some point. It should work in 11. As some discussion here and some testing, it's kind of weird right now in current land for when you're trying to put flags on certain the interface. But the idea is to turn off all the offloading mechanisms so that when these tools fire up and they're looking at the interface, you're getting the raw packet data. There's nothing going on in the network interface, just in case it's some specific attack that it will be messed with by the network card to help with performance. So you want to be able to detect it. And then that brings up netmap as far as on the FreeBSD side, which in 11 is in somewhat of an interesting state, and the code has been updated in 12, and I think there's another update that has to occur. But in 2.5, when I did the talk in June, then all this changed with the plugin. It used to be a process they had to how to build netmap plugin with Bro. It's not available yet. You can go download this code. I've already changed the slide a couple times, but this Bro package manager they've moved to is kind of making it so they want to make it so you can share detection, because they want to have a nice community where if you find something on your network, you'd be able to send a, here's, it's not like an indicator, but this is this particular attack that I'd like to write, this is what I wrote up and this is what I used. So they're using that for their plugins. So you've removed all the plugins from their GitHub repo, and you have to kind of build it outside. So I was trying to test this, and with some interesting results. I just wasn't getting it working in current. Then there's this other utility that I brought up, and it was like a great thing. If they're bringing all the netmap repo over from GitHub into FreeBSD, all we got to do is throw this other app, which adds a load balancer. And what LB does is uses netmap pipes, so I can just basically set up this interface. So I have an Intel NIC, and I can make up different netmap pipes and load balance that across Bro. In the next slide, we just have like kind of worker threads, and in the bottom you can set the number of processes you have. So you're setting, instead of having a single threaded Bro instance running, you can scale up as many pipes as you can handle with the load balancer application, and you're getting more throughput performance to be able to read your network data. And this is just output when once you do that. So another thing, as we're talking some stuff here, these are tweaks that you can do. Calomel.org is a great site for configurations and stuff I look at quite often, and some other sysctl changes. So for the top node, I think some of the ones in the bottom for like an Intel NIC might be changing. But it's the idea to turn the receive queue up and do some tweaks to be able to just set up your box so they can read as fast as possible off the network. And in addition to NetMap and trying to use like standard network interfaces, you have the ability to use, of course, Chelsea NICs, and Myricom is actually, a lot of people on the Linux side, I've talked to people in the community, they have Myricom NICs that they use for, good for performance. And of course, if you want more inline solutions, of course, both pfSense and OpenSense have a FreeBSD base of them using Snort and Suricata. There is the ability to do divert sockets. I'm not sure if anyone still runs this, because normally when I talk to people, it's like I run Snort and Suricata on a pfSense box, but you could configure it so that you have, in the next couple slides will have that for configuration you would set for Suricata and your IP firewall rules to send all traffic once it gets approved, the first part of the firewall stack to, okay, send it to divert socket. Then one of these engines will, Suricata will listen on that divert port and then make a determination. And if it's bad, you set the rule to drop. And also with Bro, even though it's not really IPS, it's always monitoring, there is going to be, you can take actions like we talked about with the blocking or the routing changes. And at some point, net control as far as for real interactive, once something happens, taking action against it. And this is just output from the Suricata port, talks about how to set up the divert sockets. And this is the firewall rule set I used to have when I did this testing. So everything goes divert, and if it gets blocked, then that's basically what you're dropping down. For hardened BSD, essentially all the tools we talked about now have all the extra exploit mitigations built into them. The other key thing is for most of these packages, if not noted, they should be giving you an underprivileged user that has access to read from the network, so you don't want to have a root user reading from in case something happens in the tool. But I think that's pretty much standard across the packages. For Dragonfly's had like this idea, and I still haven't had this test set up, but it'd be an interesting configuration, especially for logging, where you essentially have your trusted log source, and using the mirroring from another network or box on the same network, using the Hammer 2 file system to basically have where you're giving a read-only copy to analysts, so they can look at it, but they can't change the data. So it actually maintains the integrity of the log data you have with using these tools. So I haven't got this set up and working yet, but it's something that should work in principle. OpenBSD, if you want to set up your own tap, you can basically use some of the features of ifconfig to make the bridge and do that. In some way, this probably still works on FreeBSD, but trying to find some things that are interesting you can do with OpenBSD. And especially if you don't want to use OpenSense or pfSense, you just want to use OpenBSD, a lot of these features, such as what Bro has, there's other older frameworks you might be able to use for Snort, once you see a detection, to then say, go make a new firewall rule for this specific bad host. But there is ways to utilize when you have OpenBSD and PF and just get the full use of your firewall. So I'm still kind of good on time. Hopefully, the next 10 minutes should get through this. But that was just my attempt. I wanted to run across all the operating systems, where things were at, because I don't, when I come to these conferences, I talk to people, and there's just some interest with the tools. And of course, my main, with Shirk, Security Onion, the kicker is people use it because it's simple. And with some tweaks, we should be able to try to convince people to start using it. It's something you can do a BSD operating system with. And even the smallest sense, like use pfSense, use OpenSense, to get a lot of these tools that you can get for your own security monitoring. So when I started doing mainly consulting in 2012, I was not doing direct security work. I basically was, I did have some things that, like I was working with my friend to do some stuff with mod security. But most of the stuff, it's like from jumping back into it, it's like I don't like any of the tools. There's nothing, I'd used Snort since 2003, and then worked with Suricata, the guys that wrote the developers, and Bro. And there was just, the tools are just no good. And so this is actually a piece that I put in my BroCon slide, where essentially I'm talking to people that are interested in the Bro Network Security Monitor as a tool, but they're all Linux people, and I'm just a crazy BSD person. So that's kind of what I started with, where it's like, all right, well, hardened BSD has some extra exploit mitigations, but just the fact that even FreeBSD, just to have a hardened network sensor that has everything tuned down, and this is, we always talk about the network performance of running FreeBSD. And with the discussion of even systemd, not the erotic novel, you have nice it was like a nice alternative. People were starting like, well, I don't like this Linux thing. What can I do? So out of the blue, just kind of looking at stuff in 2015, Lawrence Berkeley Lab released this documentation about their 100 gigabit per second IDS solution, which just has a little caveat in there. They chose FreeBSD with Maricom cards, and they have Arista front ends. And there wasn't really a lot of news about it, talking about, well, yeah, they run FreeBSD on these systems. So I was like, there's a lot of options we could probably do with FreeBSD. So I submitted my talk to BroCon last year, and this is just a picture of their box that they have out there at the labs. So they selected it. Mainly, as I was told, the interest was in the packet acquisition. NetMap, depending on how it works out as far as for its use in FreeBSD, is this kind of packet acquisition solution that works across the various operating systems. Linux and, I think there's actually Windows source code, but mainly Linux and FreeBSD is the focus. And I was talking about the time trying to get, Antoine Jacotot was he needed to get Bro working, so I was pushing to get that stuff into the operating system. But I only knew myself and the LBL that was running Bro. And then come to find out, they treated FreeBSD as their tier 1 platform. They essentially built out in Berkeley and the other National Computer Center, Supercomputing Center, if it doesn't work on FreeBSD, they essentially do not release. Until it works on FreeBSD, once it's out good as far as for Berkeley's concerned, then they push out their release. So 2.5.1 was tested on FreeBSD, and if there was any major issues, it would have held it up. So I think my talk went well. It was one of the first talks I gave. I laughed because when I left and came back, I saw some person looking up FreeBSD, BSDs on their desktop because they pulled up the main website to look at what I was talking about. Later that month, actually in November that year, then went to talk to the Suricon because I happened to be in DC, and same thing, talks about everyone gets together, talks about various threats and things that they can do differently with the tool. I've worked with a lot of these people in the past, and they know my views on BSD. So I just wrote up, kind of like we do here for the BOF, about talking about pulled pork, because some people are interested in signature rule management, because they've used this tool. There's not really a community around it, and I try to bridge it to it's like, hey, is there any issues anyone has? Because if you don't put it on GitHub, I don't know it's a problem. And of course, at the social event, then more BSD discussions ensued. But the interesting thing about Suricata is, I think Victor Julian did work with Luigi at some point, and there is pretty good support for NetMap built into Suricata. So there's not really a SnortCon per se, but I always visit with folks that work now at Talos and et cetera, and it's an advocating for most of the community people that run network centers with FreeBSD and OpenBSD. So as the tools, kind of talking about the advocacy, but the part that I just can't get past is logs. In a sense, I don't want false positives. So try our best to, make sure we don't get alerts. Okay, well, we still having issues finding the good stuff. Okay, well, let's get everything cranked up. So now we have too many logs coming from everywhere. We got to do something about it. So we're in this progression where, when I first started, this was like an Oracle-based solution. It worked as far as for bringing in data. So analysts were watching this as alerts come in. Then you had this idea of the SIM startup for, yes, we need to aggregate everything and only give people the really meaningful pieces of data. But it's the idea that even with the SIM, it's, okay, now I want to know what actually happened. I have this correlated alert, but what led up to this? So it's like when we talk about NSM, we're splitting between the ability to really figure out what happened.
Could you expand SIM?
Security incident event management, or garbage, depending on which one you're talking about. Splunk itself, though, has its own as a SIM. When I started doing, most people are trying to deploy Splunk as their tool, so it is easy to get stuff up and running. It comes at a cost. Splunk never wants you to stop, logging data, and then you just have to make sure you have people that can configure it correctly, because as you scale up, if you started on the wrong path, all of the data you have will be different, and it's really not that easy to, re-index that data as it comes in. But it is the best, gets working, but it does require Linux. Squeal at this current time is still a port available. You still have to do all the database configuration. And there's another front end to it. It's a PHP front end. At the time, there was no port for it. But as far as okay, well, that's great. You got Splunk. What can you do on FreeBSD? And then you also have Elk. But I've seen better reports of that with Elasticsearch. I'm sorry, to go into Elastic, Logstash, Kibana. So it's the web front end, the log pipeline that you use from the system, and Kibana is just the web front end. And it does have support for the tools themselves. People have done some work on it. There is a FreeBSD port, but you need Java, and that just the scaling part's what's always been a concern for me. Graylog is supposed to be more enterprise ready. There also is a FreeBSD port for it. Also, you need Java, and there's some issues where I don't see a lot of inputs for tools. So it might work great, a little bit easier, but you might need some upfront development time to get things working. And then from the boxes themselves, you have these message queues, which I've messed with a little bit. So it's the idea that as you get multi-gigabit traffic, you're trying to at least buffer that. So as you wait for the logging tools to work, you then have the contention issues, and that's where some of these different types of queues can help to buffer the data before it gets logged, so you're not losing log data in the process. And even Hadoop, as far as yes, we need to use Java for this. But MapReduce is a good thing when you're going across a large set of data. And there actually is a FreeBSD port for it. But it's the fact that all this is Java-based. I don't know why no one has any problem with it. From the early part 2000s to now, all these people had fat Java clients that were crap. You had to always maintain the versions of Java. You have vulnerabilities in all your security analysts' desktops. Why that's, it's still a thing, unfortunately. And of course, Splunk, as far as for big data, I don't think we're almost at a point where people don't care. If I'm an analyst, I just want to, here's your workstation, here's the place you log in, do people really care? And I think that's the concern I have as far as for the technology. Security engineers just want stuff to work. They don't want anyone to call them. So, but even with all that, when I talk to folks at Berkeley, they just log text files for all these massive amounts of data they have, and they use Broda just to send an email when something bad happens. So, there is ways that we can probably do things better. That's my main concern, is just with the use of, the logging tools are just going a certain path I do not appreciate. So, in the epilogue, I am trying to work to get non-Java-based solutions, something that will work, be effective. Like I said, this might be a losing battle. At BSD Canada, Sean Critterton was not here, but he talked about belief search, so I've been interested in looking at something like Guts Go based. I thought that was kind of interesting. I started poking around with that. But pretty much the tools themselves, they were just running on a system. They're comparable to running on Linux. And I basically, when I go out and represent, I just try, it's been the goal just to talk about people can run BSD operating systems to do their network security monitoring. Things I still need to work on, even from the first time I gave this talk, the meta port. So the idea is to take all those things I had to do on FreeBSD and bring them into kind of like a BSD NSM, so someone just can go package install or, and build that. So those are the pieces that I need to get working. Like I talked about for Bro Package and NetMap, the issue was that's kind of changed things so that I don't know if that's going to turn into a port, but at least an easy way to get Bro Package set up so that you can bring in something once the NetMap plugin's put back in. And for new ports, apparently the Suricata port is in progress for version 4.0 and the 6.2. I haven't looked at it yet. This was pointed at on the email mailing list. And Pool Park needs a port bit created for OpenBSD. So I thank you, everyone. References. Thank you all.